Hey guys, in this video I will show you how to make your own language model in Python, which is gonna output something like this. Not exactly ChatGPT, but it's nearly there. To start, we need to understand exactly what a language model does. The simplest type of language model is a bigram model, in which using the last word it wants to predict the next word. As the models get larger and larger, we need to take into account the last 8 words, the last 10 words, or the last 2000. That's what you see on large language models like ChatGPT in real time. So the text in the context window isn't actually broken up into words, but instead tokens. But for the sake of simplification, we're gonna assume each token is a word. Since computers can only understand numbers, we need to encode these words into a sort of a vector, or in this case it's called an embedding, which is gonna tell the model which word it is. We will feed all these embeddings in the context window into a neural network, which we're gonna use PyTorch, and then it's gonna output an embedding of the next word that the model predicts it's gonna be. Later on, I'm also gonna add something called attention between the tokens, which is gonna help each token communicate with each other to make the model more accurate. So the first step is to acquire the training data, which I'm gonna use with the Python language toolkit library. With this command, you can download the books that they offer, and as you can see, there are 9 of them, and I'm gonna just use the first one, which is Moby Dick by Herman Melville. Next, I'm gonna build the tokenizer, which is either gonna break the text into character level tokens or a separate encoder of your choice using the TickToken library. After converting all of that to tensors and doing the train test split, we need to declare the block size, also known as context window, which is going to be the number of tokens the model can see while predicting the next word. So this language model class is going to be the main of our model, and what it basically does is just compare the model's output with the supposed target and calculate the cross entropy or the log loss for this prediction. Now this is the attention class, which is much more mathematically complex, but the basis of it is based around of this equation, where each token actually contains 3 more information aside from its embedding, which is the Q, K, and V values, which we can get by multiplying the embedding of that token with a learned weight matrix. Then we can apply softmax activation to this matrix and add this to the original embedding. Overall, this process looks something kind of like this. So this is what the model outputs after training. It looks kind of bad and random, but for now we can use the Adam optimizer to decrease the model's loss. As you can see, now the text looks much more like English, and you might even recognize some normal words. So now I'm kind of stuck here and don't know how to make the model better. So I just start messing around with the tokenizers and stuff. Well, this project was pretty fun and educational. Thanks you guys for watching. I'll see you in the next video.